A proton and an alpha particles both enter a region of uniform magnetic field B, moving at right angles to the field B. If the radius of circular orbits for both the particles is equal and the kinetic energy acquired by proton is 1 mega electrovolt, the energy acquired by the alpha particle will be what we need to find here. Here, when any charge will enter into magnetic field, their radius will becomes R is equal to mv divided by q times b. We can write this one in another format like P divided by Q times B, or under root of 2mk divided by Q times B. Then by rearranging this one on squaring on both the sides, then we get the value of the k here. K is equal to R square into Q square into B square divided by 2 times m. Since they are going to say here if the radius of the circular orbits for both the particles is equal and the kinetic energy acquired by the proton is 1 mega electrovolt, then I can say these R and B are equal here. Then K is directly proportional to the Q square over m here. And the K of the alpha particle is I can represent as a K alpha divided by K proton is equal to then Q of alpha divided by Q of proton whole square into mass is inversely proportional. Then this is mass of proton divided by mass of alpha. Then K of alpha is equal to we can write this Q by Q alpha by Q proton. We can take the ratio is 2 by 1 whole square into mass of proton by mass of alpha is equal to, that is 1 by 4 into 1 mega electrovolt. We can write multiplied by 1. Then K alpha is equal to 4 into 1 by 4 into 1. We get the answer K alpha is equal to, that is 1 mega electrovolt. Option A is the right answer here.